All right. So how do you find the domain and range of the function f of x equals 1 over root of 1 over x minus 2? Okay, so in a lot of different lessons, I've described what the domain and range are, but I'll do it again. So for the domain, it is all the values of our number sets that define our function. And what that means it defines our function is that it maps to a legitimate value. It maps to a defined value. So what undefined values are basically like infinity, negative infinity, or like discontinuities, right? So the domain is basically all values of, let's say, x that define our function. So the function is kind of like a bridge that maps our value of x within our domain to what our values in our range. So the values in our range, and I'm going to describe it as f of x, is all the possible values that are mapped from our domain. So the domain and range of a function varies with different kinds of families of functions. In this case, we're given a rational function with a numerator of 1 and a denominator of x minus 2. Okay, so one of the ways that we find a domain is by doing the opposite. We find the values of the function which are undefined, right? And by finding the values of the function that are undefined, we're able to exclude that out of our domain. So that's one way that we find our domain. The other way that we find our domain is by we just graph it and we visually locate all the discontinuities and everything that it does not exist on the function. Finally, the last way is that we can calculate the limits of the function, but that's beyond the scope of this question so far, so we won't cover it. Finally, the range. So the range is closely related to the domain, and the fact that if there are values of the domain that are restricted, that most likely means that the range might also be restricted to that value that's mapped. So one way that we can calculate the range or find the range is by also visually graphing it. But my personal favorite is to calculate the inverse of the function. And by calculating the inverse of the function, and we write notation as f of inverse of f to the power of negative 1, we basically calculate the domain of our inverse. Okay. So what this means is that if the function maps a value of x to a value of f of x from domain to range, the inverse reverts that. It maps a value from our f of x of our range of our function back to the domain of the original function. So that means that the range of the original function is the domain of the inverse, and that the range of our original function, or the domain of original function, turns to be the range of our inverse. So we're going to use this technique to calculate the range of our function. Okay, now moving along. So first we want to find the domain of our function. Okay, and let me write out our function again. F of x is equal to 1 divided by x minus 2. So like I said, a very easy technique is to find all the values of x which make our function undefined, and that's very simple. All we need to find is, in this certain family of functions, is we need to make sure that we exclude all the values of x that make our denominator equal to 0. Because when anything is divided by 0, we have an undefined value. Okay, so that means that we want to set x minus 2 to be equal to 0, and that is x equals 2. So therefore, our domain is equal to x belongs to all real values, except x cannot equal to 2, because when x equals to 2, our function is undefined, as you see here. So all other values of x in the real number set is valid, but x equals 2. Okay, now we want to find our range. So this one's really simple. So the easy way that I find the inverse function is first I switch my x variable and my f of x variable. Okay, so x equals 1 over f of x minus 2. Then I isolate for f of x again. So if I'm isolating for f of x, I'm going to move it to the left-hand side by multiplying both sides by f of x minus 2. Then I get rid of x by dividing both sides by x. Okay. And then I get rid of this 2 by adding both sides by 2, and we get 1 plus 2x divided by x. Okay. So now I write this notation here. F of inverse x is equal to 1 plus 2x divided by x. And we calculate the domain of our function here. And similar to this rational function, we see here that our domain of our inverse is equal to x belongs to all real values, except x cannot equal to 0, right? Because when x is equal to 0, the denominator is equal to 0. And this equals our range. So our range is equal to y belongs to all real values, except y cannot equal 0. Okay? Cool. So other than that, the solution is correct, and we can move on. Finally, let's talk about our last question of the day.